Good evening, class. So today we are going to discuss an important topic in the aspect of physics, that is the physics and mathematics. In the earlier class of physics, we had already discussed about the measurement, and we had got some inputs regarding the measurement in that topic. That is, measurement means to compare an unknown quantity with a known fixed quantity. An unknown quantity may be the weights which we are placed on the left hand side of the pen, and the known quantity may be the standard units such as kilogram or meter, length, etc. So in the nutshell we can say that measurement means to compare an unknown quantity with a known fixed quantity. This topic measurement we had we had already discussed in our earlier class, in the class of concept of physics. So today we are going to discuss about the new topic in the concept of physics only, and in the series of concept of physics we are going to discuss a new topic, that is the physics and mathematics, the involvement of mathematics in the physics aspect of in the aspect of physics. We have how the mathematics plays a vital role, how it is applied in the various, you can say, arenas of physics. So we will be discussing some of the important concepts related to mathematics which are induced with the physics, which we are using in the day-to-day life, and how we are applying the mathematics in order to solve the complex numerical problems in the physics. So there are certain topics which we are going to discuss today in the physics and mathematics section. The first and foremost, we will be discussing about the vector quantities. Secondly, we are going to discuss about the scalar quantities. Thirdly, we are going to discuss about the equality of the vectors. So these three are the important concepts. These three are the first and foremost important concept in the, you can say, concept of physics. So as to move to the next section, so as to proceed further in the other concept of physics. The first and foremost, what is the vector quantity? The vector quantities are the quantities which are having both magnitude as well as direction. These quantities are having the both magnitude as well as direction. Magnitude, it means, suppose we are taking the example of a you can say force. Force we had already known, that is SI unit of force is Newton, and we will be differentiating the scalar quantities as well as vector quantities too. The first and foremost, we will be diving into the definition of the vector quantities. The quantities which are having the both magnitude as well as direction, these quantities are defined as the vector quantities. The vector quantities are such as the weight. Suppose if we want to measure the weight of a particular quantity, and we had defined that and we had assumed that particular weight, the magnitude of that particular quantity, is traveling along a particular direction. Suppose a weight of 5 Newton is traveling along a northwest direction, or it is you can say moving upwards or going downwards. So in that you can say in that situation, we had described the particular quantity with the two known entities. We had given the magnitude also, that is 5 Newton, and we had specified a particular direction. That is, we had specified a particular direction pertaining to that quantity in the northwest direction, or it is going outward, or it is going upward or downward. So the quantities which we are describing with the direction as well as, you can say, magnitude, such type of quantities are defined as vector quantities. The quantities which are defined by direction as well as magnitude, those quantities are defined as the vector quantities. Now switching over to the scalar quantities. The second topic which we are going to discuss, it is basically the scalar quantity. The scalar quantities are those quantities which we are describing only with the you can say magnitude. In this scalar quantities, direction will not play a vital role. Direction will have no role in this scalar quantities. Suppose we can describe a particular scalar quantity with the help of magnitude only. The no direction will be there in that case. So see, suppose we are considering a mass of 10 kg. A mass of 10 kg. In that case, the direction is not specified. Direction will not play a vital role. Only we can describe a particular quantity with the help of its magnitude, that is 10 kg. So this type of quantities are defined as scalar quantities, whom we are describing with only one of the parameters, that is magnitude. There are certain quantities which we are describing with both the parameters, such as magnitude as well as direction. Those type of quantities are defined as the vector quantities, and the quantities which we are describing only with a single parameter, that is, you can say magnitude, that type of quantity, it is known as the scalar quantities. So we will be differentiating the scalar quantities and vector quantities. The first and foremost parameter will be, suppose that in this case, if any particular quantity is there, and when we are describing that particular quantity with the two parameters, that is magnitude as well as direction, those type of quantities are defined as vector quantities. And the quantities which we are able to describe with only one parameters, that is magnitude, then those type of quantities are known as the scalar quantities. Now the third topic. The third is the equality of the vectors. In this case, we will be seeing the equality of the vectors. This particular topic, it is very much related to the mathematics, and we had already studied this type of topic in the earlier section also, and we will be diving into the I will be diving at a grassroots level, and we will be defining those type of vectors also. Equality of two vectors. Suppose there are two vectors are there which we are describing with a particular magnitude as well as direction, and suppose the equality of the two vectors, when the two vectors will be equal, if their magnitude as well as direction are equal. So when we are describing two particular quantities, when we are talking about the two particular quantities, suppose both the quantities are having the weight of you can say suppose both the quantities are having the weight of, you can say, 5 Newton. Okay, so both the quantities are having the same magnitude, and when we will be specifying a particular direction, we will be allocating a particular direction, both are having the same direction, then in that case we will be finding that both the parameters are same. The parameters are magnitude as well as direction, both the parameters are same. In that case we will be concluding that both the vectors are equal, and we will be defining those entities as equality of the vectors. So as I had already given one example of weight. Suppose we had taken two quantities, and we had allocated a certain weight. Suppose 5 Newton is there, and the second object is there which is also having the 5 Newton, and both the quantities are moving in the both the quantities are going upward. So in that case, no matter how much distance is there in between both the quantities, how much height is there, how much difference in height is there, there will be you can say we don't have to consider about the height and all, but we have to see whether both the quantities are traveling in a particular direction, in the same direction, and both the quantities are having the same magnitude. Then and only then we will be saying that both the vectors are equal, and we will be saying that there is an equality of vectors is, you can say, exists. There is an existence of equality of vectors between the two quantities. So the thing is that we will be slowly going to this topic, that is the addition of vector. Now we will be switching over to the addition of vectors. In the addition of the vectors, we will see some of the terms and conditions. Some of the cases we will be seeing which will be beneficial for us to understand the, you can say, further concept. In the long run, there are certain concepts are there which we have to understood, and we have to apply. This is a particular branch of mathematics only, and we are, as we had already studied in the earlier class, that mathematics is the language of physics. So we will be applying this particular the concept of vectors, and so as to understand the various, you can say, laws and principles of nature, that is physics. So first and foremost, the addition of vectors. Under the addition of vector, under the heading of addition of vectors, there are certain terms and conditions. The first and foremost, if the two vectors, suppose we had considered the two vectors, suppose we had taken the two vectors, vector A and vector B is there. So in this case, the vector A, the last portion of a vector. There are two portions of a particular vector. If we had allocated a particular vector A, so in this case the left portion is known as the tail of the vector and the right portion is known as the head of the vector. Suppose in this case, in this type of sum, if the two tails of the vector, suppose there are two vectors are there, vector A and vector B, and both of their tails are coinciding. Both of their tails are coinciding because we had already specified a particular direction, that this type of vector is moving from left to right and this type of vector is moving from down to bottom. So in this case both the tails of the vector will coincide. So for that we had drawn a diagram, or we had drawn a schematic diagram which will depict, which will certify my statement. So in this case we had seen that this type of image will come if both the tails are coinciding. There are certain cases in which one of the vector is moving from you can say bottom to top, and one of the vectors is moving from, and the other vector is moving from top to bottom. In that case there will be different situation, and we will be seeing that also. The first and foremost we will be seeing the terms protocol number 1. In that case we will see both the tails are coinciding. So we had already taken the two vectors, vector A and vector B, and based on this schematic diagram we had found that the resultant of both the vectors, is A plus B. This particular line denotes the A plus B. So in that case, in this case we will be finding the, you can say, the magnitude of A plus B and the angle of inclination of A plus B, the resultant, the angle of inclination of the resultant, that is A plus B. So we will be applying the simple laws of the mathematics, and we will find the magnitude of A plus B and the angle of inclination of A plus B in this case. So first and foremost we will see that this particular A plus B, how we can find the A plus B. The A is given here, okay, it is 90 degrees there. It is 90 degrees there, and the first and foremost this is theta, this is also theta, and this is vector B. So when we will be applying tan theta, it will be perpendicular by base. So when we will be applying the tan theta, it will be perpendicular by base. We have to calculate B. So B is, you can say, cos theta. Cos theta is equal to base by height. Base it is B, base by hypotenuse. The hypotenuse it is vector B. So we will find BE is equal to B cos theta. So we had found out the value of B in the term of cos theta. So B is equal to B cos theta. So now we will be applying the certain rules and regulations in this. So it will be easy for us to solve the particular problem. First and foremost, we had calculated B simply by using the laws of trigonometry. Cos theta is equal to base by hypotenuse. So in that case the cos theta will be equal to BE by hypotenuse BD. So BE is equal to B cos theta. So this is the expression which we have got. First and foremost, this expression which we had received. Now we will be applying the Pythagoras theorem in order to deduce the magnitude of A plus B. Now see, in this triangle, in the triangle AET, we will be finding here first and foremost. Now I am rubbing the topic part so that I will be getting some space so as to reduce the relations. So first and foremost, we will be considering in the triangle AET. So first and foremost, AD square is equal to AE square plus ED square. Understood? Now we have received the AE part. First and foremost, the AD square is equal to, this portion is equal to AE square. Now how we will be writing the AE? It is the summation of angle A, it is the summation of vector A plus B cos theta. So it will be summation of AE will be A plus B cos theta the whole square plus ED square. Now we will be checking the ED portion, this portion ED. So ED will be equal to sin theta is equal to perpendicular by hypotenuse. Sin theta is equal to ED by B. Sin theta is equal to P by X. ED is equal to B sin theta. B sin theta. We will be writing here ED B sin theta the whole square. So we had got the inputs in the term of sin theta and the cos theta. Now we will be expanding this particular expression A plus B cos theta the whole square in the term of A plus B the whole square. As we had already studied in the earlier class, A plus B the whole square is equal to A square plus B square plus 2AB. Now we will be applying to those concepts here. A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. Understood? So it will be A square plus 2AB cos theta plus B square. Now we will be taking common. We will take common in these two, the second term and the fourth term. B square we have taken out. Sin square theta plus cos square theta is 1. So we will be writing here B square into 1. So we have got the expression A square plus 2AB cos theta plus B square. Understood? So we have received the AD square part. It is, and when we will be writing AD, it will be under root of A square plus 2AB cos theta plus B square. So when we are removing the root part, we have received the AD portion, that is the value of that is the magnitude of A plus B, A square plus B square plus 2AB cos theta, and over root of that. So AD is equal to under root A square plus B square plus 2AB cos theta. Now we will be deducing a particular relationship which will depict the inclination of that particular resultant, that is A plus B. The inclination of that particular line, we will be checking the other relation also. So first and foremost, we will check what is the value of, whenever we are talking about the inclination, we are taking we are taking the tan theta into our consideration. So in this particular triangle BED, in the triangle BED, in triangle you can say AED only. Okay, AED. So tan alpha is equal to perpendicular by base. So in this case perpendicular will be DE. Perpendicular will be DE. Okay, and the base will be same, AB plus BE. So AB plus BE we have already considered here, that is A plus B cos theta. A plus B cos theta. And the above portion is DE. So DE we had already calculated. We had already calculated this B sin theta by A plus B cos theta. So we had got the input. We had got the angle of inclination. Angle of inclination is tan alpha is equal to B sin theta by A plus B cos theta. So this type of particular problem, which we are commonly, we are commonly finding it whenever the two vectors coincide and they are coinciding in the aspect of their tails. The two vectors will coincide whenever the tails are coinciding. We are using this concept so as to find out the value of the resultant, that is vector A plus vector B, and the angle of inclination of that particular line, that is vector A plus vector B. We had already got this input. So secondary part we will be describing here. First and foremost, we will check this is the first condition. This is the first condition when the two vectors will coincide, when their tails are coinciding. Now we will see when head of one vector will coincide with the tail of other vectors, how we are calculating the resultant in that case. We will be checking, we will be seeing those. So I am just rubbing it. So in the second case number 2, we will be seeing when the head of one vector will coincide with the tail of other vectors. In that case, how we are calculating, how we are determining the you can say resultant of that particular vector. So in this case, when head of one vector coincide with tail of other vector. Okay, so we will be seeing some of the particular example here. Suppose this is a particular vector. This is moving in this vector A in this direction, and this is the vector B. This is moving in this direction. Okay, so we are seeing here this particular vector is moving from left to right, and this particular vector is also moving from down to top. Now this is the coinciding, this is the intersection point. This particular point is known as the intersection point. This is the intersection point. Intersection. So in this case, this is the tail, this is the head, and this is the head, this is the tail. So I had already stated the required, you can say, parameter here. So the two vectors are coinciding in such a way, the head of one vector is coinciding with the tail of other vector. So in this case, we have to join this particular point. By using the dotted line, I am joining these two vectors, and this particular line, this dotted line, will be the resultant of these two vectors. So I had denoted the resultant of these two vectors in the term of the dotted line, that is A plus B. This is the particular resultant of the two vectors. Whenever the two vectors will coincide in such a way, the head of one vector will coincide with the tail of other vector, and we have to join the tail of one vector with the head of other vector, and we will be getting a line that is in the dotted line, in the terms of the dotted line, and then that dotted line will denote the resultant of the vector A plus B. So this is the case 2. Now we will be seeing the subtraction of the particular vectors. Subtraction of any vector. Subtraction of a particular vector. Particular vector. So when we are talking about the subtraction part in the context of the vectors, in this case we will just add the two vectors, but we will reverse the direction of any one of the vector, and that particular operation will also be defined as the addition, but the vector, the direction we had already changed. And finally we will be getting the you can say the subtraction part of that vector. I will show you one example. Suppose this is the vector A and this is the vector B. Suppose I have taken one example. Suppose this is the vector A. Suppose this is the vector A is there, and we will be taking one vector B. Suppose this is the vector B. Okay. So in this case, the tail of one vector, this is the tail, this is the intersection point of these two vectors. So the tail of one vector is also coinciding with the tail of other vectors, and we have to calculate, in this case we have to just show how we are depicting the subtraction of the two vectors and how we are calculating the resultant in that case. So we will be, suppose we have to calculate vector A minus vector B. So we can write here in this the vector A plus minus vector B. So in this case, suppose a vector B, it is moving from the, you can say, bottom to the top. We have to reverse the direction of vector B, as we had already seen that negative sign is there. So we have to reverse the direction of vector B, so that we will be getting the operational result of subtraction of vector A plus and minus B within the bracket. So we will reverse the direction of vector B with the dotted line. So it will be minus B, and whenever we will join these two vectors, so it will be the resultant A plus minus B. So this is the schematic diagram. This is the representation point of the schematic diagram, how we are calculating the resultant in the case of the subtraction. In the case of addition, it will be simply we have to add A plus B. In the case of subtraction, we have to reverse the direction of a particular vector and we have to add. so that we will be getting the subtraction of the two vectors. So these are the certain examples. This is a particular schematic diagram which is depicting the subtraction of vector part. Now we will be switching over to the multiplication of the vectors. In the case of multiplication of a vector, it will be an easier part. We will just take some example in that case. Multiplication by a vector quantity. So in this case, whenever we want to multiply a certain quantity with any vector, so we will be denoting, we will be using a nomenclature in that case in such a way that this direction shows the vector A, and we have to multiply this particular vector with the k. K may be any natural number. K will be any certain quantity or any natural number through which we have to multiply this particular vector A. So we will be getting the final product as vector A into K, and we can denote this particular vector B. So the resultant of this vector, the resultant of the multiplication of the vector A and K will be vector B. Vector B is equal to vector A into K, and this particular vector B, it will be having the same direction as that of vector A. So in this case, the direction of the vectors will be the same in the case of multiplication, but we can multiply a certain quantity with a vector quantity, so that we will be getting the final result as vector A into K, where K is any natural number or any certain quantity. So this is the particular resultant of this multiplication. Now we will be switching over to the cross product and the dot product. We will be switching over to the cross product and the dot product of a particular vector. So first and foremost, we will be saying the dot product. In the case of dot product, suppose this is the particular A vector is there, dot, we are using the nomenclature as dot. So it will be magnitude of A, magnitude of B into cos theta. So in the case of the dot product, this particular you can say multiplication of vectors, under the subheading of the multiplication of the vector, this is an important concept which is entitled as dot product. We are using this particular equation in the case of, you can say, in the case of work, whenever we want to calculate the magnitude of work, in that case we are using this particular equation in the terms of physics. So in this case, we have seen vector A into vector B, it will be vector A dot vector B is equal to magnitude of A into magnitude of B into cos theta, where theta is the angle between the vectors A and vector B. So suppose we want to calculate the work done. We had already known work done is equal to force in dot product of S. Work is equal to F dot S. Where we will not say force into S. We will be saying like that, work is equal to F dot S, where F denotes the force and S denotes the displacement. Work is equal to force dot displacement. So F dot S is equal to vector magnitude of F, magnitude of S, and the angle between these two, cos theta. So work is equal to Fs cos theta. Work done is equal to Fs cos theta, where theta is the angle between the force and the displacement. So in this case, there are certain terms and conditions. As we have used cos theta here, so the case 1, when theta is equal to 0 degree. So when theta is equal to 0 degree, in that case we will be substituting the value of theta in the particular equation number 1, and we will be receiving sin theta is equal to sin 0 is equal to 0 and cos 0 is equal to 1. So we will be getting theta is equal to 0 degree. So in that case, A dot B is equal to vector A, magnitude of vector A into magnitude of vector B. Okay, and magnitude means A by under root A square into B by under root B square. So this is the particular resultant whenever the both the angles, both the vectors are moving in the same direction. So in that case, both the vectors will be, the angle will be 0 in that case. Secondly, when theta is equal to, both the vectors are moving in the same direction. Suppose this one is the question vector A and vector B. So the angle between these two will be 0 degree or 180 degree in that case. Suppose when theta is equal to, both the angles are moving in the same direction parallelly. When theta is equal to 90 degree. Suppose when theta is equal to 90 degree, both the vectors are mutually perpendicular to each other. So in that case, we will be substituting the value of theta is 90 degree, and the cos 90 is equal to sin 90 is equal to 1, and the cos 90 is equal to 0. So the cross product will be, the dot product will be 0. Whenever both the vectors are mutually perpendicular to each other, then in that case the vector A dot vector B is equal to 0. Thirdly, when theta is equal to 180 degree, in this case vector A and vector B, the resultant will be 0. It will be 90 degree and the resultant will be 0. When theta is equal to 180 degree, whenever both the vectors are placed in such a way that the angle between those two vectors are 180 degree, or the angle in a straight line. So in that case, we will be substituting the cos 180 degree. So cos 180 degree, we will write here cos 180 degree minus 0 degree. And we had already learnt about the sine rule. In the sine rule, we had discussed that in the second quadrant up to 180 degree, the sine will be positive, sine sin, the trigonometric ratio sine will be positive and cosec will be positive. So we will be seeing here 180 minus 0. In this case, we will be writing here minus cos 0, or sine 0 is 0 and cos 0 is minus 1. So it will be cos 0 is 1. So it will be minus 1. So the resultant will be minus of vector A into vector B, the negative part of the vector A into vector B. The A dot B is equal to minus of magnitude of A and magnitude of B. So these are certain terms and conditions whenever we are using the dot product. Now we will be switching over to the cross product of two vectors. The cross product of two vectors. We will be seeing the cross product of two vectors. Cross product of two vectors, vector A cross vector B. That is the cross